Hello and welcome. In this video, I will explain you a very interesting topic, demultiplexer as a universal logic. Now in the last video, we discussed how demultiplexer can be used as a universal logic. Now in this particular video, we will try to see how to make decoder using Demux or demultiplexer. And if you know the concept of demultiplexer as a universal logic, you will find this video very simple. Now, if you don't know the concept of demultiplexer as a universal logic, please go and watch that video. And after that, you can watch this video. Now see, this is what the simple diagram of 1 cross 2 Demux, which consists of one input A, one select line, and the output is in terms of product, right? A S bar, because this S here 0 is right, to A S bar, and here AS. Very simple. Now see how to make NOT gate and buffer using this 1 cross 2 Demux. Just connect 1 and at select line connect A. So it will become A bar into 1, which is nothing but A bar. Okay, so this is NOT gate. Similarly, this 1 into A. So this is what buffer. Now, if you know the concept of encoder and decoder, you should know that encoder contain 2 raised to power n inputs, whereas n outputs. Let me repeat. Encoder has 2 raised to power n inputs and n outputs. So we can make 2 cross 1, 2:1 encoder, 4 to 2 encoder, 3 to 8 encoder, 16 into 4 encoder. Similarly, decoder has n number of inputs and 2 raised to power n outputs. 1:2 decoder, 2:4 decoder, 3:8 decoder, and 4:16 decoder you can make. Now in this particular video, we will see how to make decoder 1:2 and 2:4 using 1 cross 2 Demux. Now let's start. As you know, the decoder, A input, D0 and D1, 2 output. Okay, 1:2 decoder. So the output will be A bar, D0. This is what 0 and 1. Okay, and D1 is equal to A. Now see this table. A is equal to 0, 1. So output is equal to 0, D0 is equal to 0, and D1 is equal to 1 by following this diagram. This is what a logic diagram of 1 cross 2 decoder. A is equal to 0, so D0 is equal to 0, C, and D1 is equal to naught of that, so D1 is equal to 1. Similarly, if A is equal to 1, so D0 is equal to 1, and this D1 is equal to 0, naught of this. Very simple. Now, if you want to make decoder using demultiplexer, just you need to map this diagram, NOT gate diagram, with this decoder. Now make a black box, something like Verilog. In Verilog, we are considering black box while modeling using behavioral coding style, right? Now make a black box, connect input side with A, and this is what the output, D0. What we want, A bar, and here D1. What we want, A. This is what. Okay, just make a black box. Now inside this black box, we need to map this 1 cross 2 Demux. Very simple. Now just make 1 cross 2 Demux. Now see, this is what 0 and 1. At input, this is select line. Okay, now we want A bar and A. Very simple. This is just a NOT gate and buffer. Just connect A here and add just connect 1 here and add select line, connect A. So at the output we will get this A bar, right, into 1, which is nothing but A bar, and here A into 1, A. just connect this with this and this with this, and this A connect to selecting. Very simple. This is what the decoder 1:2 decoder using 1x2 Demux. Very simple. Now similarly for 2 to 4 decoder, what we need to do, just we need to map this diagram with this black box. Make a black box like this and connect A, B, this A, B, and D0, D1, D2, D3, D0, A bar, B bar, D1, A bar, B, D2, A, B bar, and D3, A, B. Just map this diagram with this. Now see, very important, very interesting. This is what the table, truth table, you can verify for 2x4 decoder. Now see what we want, A bar, B bar here. Okay, so for getting A bar, B bar, just make 1x2 Demux. Now here we want A bar, B bar, and here we want AB. Okay, how to get A bar, B bar? If you connect A here and B here, so what we will get, A, okay, this B bar, we will get this B bar. Now make this as a first, make like, now as you know, whenever we connect A here, so we will get A, this B bar, right? And here at this output, A and this B. Very simple. This A and B bar, this A, B. Now this A, B bar is here. Just connect this A, B bar to here at D2, A, B bar, and AB is there, right? So just connect this AB to this D3. Very simple. Now we want here A bar B and AB bar. For that, just make 1x2 Demux, take 0, 1. Now see, as you know, if we connect B here, here we are getting B bar, okay, and here we are getting B. Now we want A, B bar. Now we want A bar, B bar, and this A bar, B. Okay, now see, if I connect A bar here, then the output we will get this A bar and this B bar, right? And here this A bar, B. Very simple. Now this connect A bar, B bar to D0, and this A bar, B. Take this A bar, B and connect here D1. Very simple. Now for getting A bar, we need to connect one NOT gate. And how to get NOT gate? 0 and 1, 1x2 Demux. Very simple. This is what A, this is what 1 to get this NOT gate, and this is at select line A. So here we will get A bar. Just connect this with this. Very simple. Now A we want, just connect this A to here, and here B we want, right? Select a line. Just take this B and connect here. This is what a very simple decoder 2 to 4 using 1x2 Demux. And you can make 3:8 decoder also, 4:16 decoder also. Very simple. So this is what all about how to make decoder using 1 cross 2 demux, because demux is also a universal logic, right? So I hope you enjoyed this video and you have understood how to make decoder using demux. Very important and very simple. So thanks for watching. Thank you.